Good afternoon, everyone. My name is Xiao Ma. I'm honored to be here to discuss our study on configuration errors in both commercial and open source systems. And this is joint work done by my group in UCSD and NetApp. So let me start with a question. So how many of you had trouble with configuring your computer or smartphone, tablet, anything? Oh, a lot of you did. So how many of you think actually it's not entirely your fault? So it's just that the stuff is hard to configure. It seems like more people raise hand. As we all know, configuring computer is not easy. And configuring such a server system is even harder. So we get the opportunity to look into a customer issue database from an industry-leading system vendor. And when we look at the root cause of all this, the customer-reported issues, this is what we find. Actually, configuration caused the most high-priority issues among all the root causes. So one of the biggest reasons configuration is such a big problem is that sometimes it's very hard to attribute the responsibility when configuration error happens. Is that user's responsibility or developer's responsibility? And this is reality, like the title of this session. So they blame each other. And because they blame each other, so no one takes responsibility. The consequence is when developer make the configuration interface, they don't think too much about the user. And once a customer reported issue turns out to be a configuration error, the developer just pull their hands off. Okay, it's not my problem anymore. It's not a bug, so I can do nothing about it. And we really think developers should actually take more responsibility for configuration errors. But the real problem is how to do it. So for example, there are many hard questions to answer. Like, what kind of configuration errors do users make? What kind of configuration parameters are more error prone? So if we know this, maybe we can avoid using those kind of parameters. Or what kind of user action can cause configuration errors? So if we know this, maybe we will double check configuration after user apply those actions. And all these are hard questions. And we believe to answer them, we need understanding of real-world configuration cases. That's the object of our study. So first, we want to understand the characteristics of real-world configuration errors. And more importantly, we want to find the implication to developers, which means what do they mean to developer? How can they improve their system? But unfortunately, we find there are several challenges. First of all, the configuration errors are not recorded rigorously. Unlike bugs, they are recorded very well with issue tracking system. And the configuration errors are usually spread out in forums, mailing lists, or customer support portals. And the second, configuration errors are usually very hard to understand. Because unlike a bug, the fix is usually just a patch. But for configuration errors, it's essentially just a conversation between users and the people who try to help. So it's not a structure. It requires a lot of manual effort to understand them. So what we did is this. We randomly sampled configuration errors from different sources. And we only chose those resolved cases in the recent 2 years to make the result more relevant. And we also ensure our sample size is big enough so our result is actually meaningful. And we also calculate all the statistical errors for all the results appearing in the paper. But I will not put those errors here in the slides just to make the slides clean. And when we categorize errors, we tried our best. Every single error is reviewed by 2 of our co-authors, and we make sure all the statistics are consistent. And once we cannot understand it, we try to get help from developers. And this table shows our data source. So in total, we collected 546 cases. And more than 300 of them are from a commercial storage system. And we also collect cases from open source systems, they are CentOS, MySQL, Apache Web Server, and OpenLDAP. So these systems are all representative, widely used open source systems. And we randomly sampled about 60 cases for each of them from forums and their mailing lists. And just like any other characteristic studies, we also have some limitation. So first, we studied only user-reported cases, reported errors. So that means some errors may resolved without reporting to the mailing list or the customer support system. And the second is we only focus on server-side systems. So because the server-side system, the reliability and availability is more important, and they are harder to manage. And we believe other type of system, for example, consumer products, may have different characteristics. Okay, let's start off our findings. We mainly studied four main aspects. The first is type. So what are those configuration errors? Reaction. So how do systems react to configuration errors when they happen? Cause. What's the root cause? Why these configuration errors happen? And impact. How do these errors impact the system? And in this talk, due to limited time, I will only cover the first major aspects, type and reaction, and I will be light on cause and impact. So for the rest of the details, you can check our paper. Let's get started with type. So from high level, we categorize configuration errors into three major types. Parameter errors, which are caused by a wrong parameter. For example, the user may set the number of threads to -5 or 3,000. Compatibility errors, which are caused by incompatible software component. For example, the user may upgrade the system partially, and some new library is not compatible with some old libraries. And other errors, which are referring to the remaining software configuration errors. So this graph shows the distribution of these three types of errors. And the red bars present the parameter errors. As you can see, most of the configuration errors are actually parameter errors, which is not surprising. So this indicates the system should expose fewer configuration parameters to the users. And if it's possible to automatically configure the system should do that. But interestingly, we also find there are some other errors which are not directly caused by parameters, and there are a big portion of configuration errors actually fall into that category. So we want to remind the developer also pay attention to that kind of errors. So since parameter errors dominate, we want to know more about the parameter errors. Let me give you two examples first. So this example is from the commercial system, where the value of this configuration entry should only contain lowercase characters. But when the user put DEV in uppercase, this causes the specified system cannot be recognized. And the second example is from MySQL. So when user sets auto commit to be true, the system will commit after every single modification operation, which may cause performance problems. So there is actually a fundamental difference between these two errors. For the first one, because it violates the format rules, so this value is invalid no matter regardless of user's intention. But the second one, both true and false are acceptable values. So it's very hard to, usually it's very hard to determine which one is actually correct, which one is not. So based on this observation, we categorize parameter errors into two major types: illegal parameters and legal parameters. And to notice here, legal parameters does not mean correct parameters. It just means the parameter is acceptable by the system. And here's the distribution. Maybe some of you may think there are fewer illegal parameters because they are relatively easy to be detected. But actually, the reality is different. So we found both illegal parameter and the legal parameter contribute the similar amount of parameter errors. So apparently, illegal parameters are relatively easy to detect, and we find half of the parameter errors are illegal parameter errors, which is kind of a good news, because it's kind of low-hanging fruits, which can be easily improved by developers. So since illegal parameters are relative to be detected, we want to know more about the patterns and the characteristics about the illegal parameters. So we developed a very complete taxonomy for illegal parameters, but right now I will only briefly introduce some high-level categories. So based on what kind of constraint the error violates, we categorize them to value errors, which violates value constraints, and the format errors, which violates format constraints. And within value errors, we find a lot of them involve inconsistent values. So then we further categorize that into inconsistent value errors and other value errors. So before I show you some concrete example, let's first take a look what's the distribution. The red bar represents inconsistent value errors. As we can see, for most of the system, most of the illegal parameters errors are actually involve inconsistent values. And the green bars represent the format errors. As we can see, all the systems have some format errors, especially for OpenLDAP. It has a lot of format errors. It's because OpenLDAP's configuration format constraint is very complicated. So let me show you some example. So this example is inconsistent value error. It's from MySQL. So basically, the first parameter specify where to output the log. And the second parameter specify the log file name. So these two should be consistent in certain ways. So if the user wants to put the log into a table, the user should set the first one to be table and do not set the second one. If the user wants to put the log to a file, the user should set the first one to be file and set the file name to the second one. But in this example, actually they are inconsistent. And the second example is when the user tries to configure PHP and MySQL work together. So the configuration in PHP means how many concurrent connections the PHP expects to connect to MySQL. And the second one in MySQL means how many concurrent connections MySQL can accept. So it's obviously the first number should not be bigger than the second number. So one is bigger, and sometimes you cannot get a connection. And more importantly, the second example, this consistency actually across different systems, which makes it even harder to diagnose. So lesson we learned here is value consistent constraints are very error prone, and they account for most of the illegal parameter errors. And they can also across multiple systems, which make it even more difficult to detect. So I will show you some example about the format errors. So this example we just showed about from the commercial system is a format error. So in this case, it would be better if the system can just accept uppercase letters or make the value just case insensitive. The second example is from OpenLDAP. So basically, before the user uses P policy as an overlay, the user needs to include the schema file first. So if they miss this include statement, it will cause the server to fail. And the third example is from Apache. So when the user includes these extensions, actually the order matters. So in this case, they should reverse the order of these two .so files. So these problems are actually, if you look at them, they are non-intuitive. Because intuitively, when I include extensions, I should not be worried about ordering. Intuitively, when I put a string, I should not about case sensitive or case insensitive. So the lesson here is format constraints are also difficult to follow, especially those non-intuitive ones. Because some previously HCI study shows one of the major reasons people make mistakes is we trust our intuition. So if you violate the intuition, people may make mistakes. And we also find the format errors are relatively easier to be detected than value errors because their rules are usually simpler. And that's probably why we found the less format error case than inconsistent value cases. Okay, the second aspect is about reaction. So how systems react to configuration errors. So when configuration error happens, what do we want the system to react? Because it's just a configuration error. And I think most of us want the system to pinpoint the error, and also would be better if it tells us how to fix it. And we call it pinpoint reaction. That's the best reaction we can expect from the system. And on the other hand, the system may just fail quietly, which is the worst case, because it looks like a bug. And there are also cases in the middle. So that's our categorization for system reaction. Let me give you some good example about the reaction. So this one is from the commercial system. The symptom is the user cannot create a new directory in a certain directory. And as a reaction, the system prints out this message. If you read this message, it's very clearly tell you what's going on and tell you how to fix it. Two approaches. Another good example is from MySQL. I hope you can still remember this MySQL case where these two values should be consistent. And later on, MySQL developer actually committed this patch. So this is a patch. It's not originally in MySQL when they introduced these two configuration entries. And what this patch does is very simple. So what this patch does is, when it finds the user specify the log file name, but they set the log output option not to be file. So it will print out a warning message saying, okay, you set the file name, but we will still put the log in the table. So these are very, very good reactions I think all the developers should learn from. So let's take a look at the distribution. So this graph shows the distribution of different kind of reactions. And for some case, we cannot get the concrete type of reaction because we have limited information and we mark them as unknown. As we can see, only a very small portion of the case system give pinpoint reaction, the good reaction. And a pretty big portion of the case, the system just fail quietly. And make it even worse, sometimes the system will crash or hang or have very significant performance degradation. So it just looks like a bug. And the lesson we learn here is that the systems should avoid these kind of bug-like reactions when just a configuration error happens. So this will very confuse the user. Because we mentioned that illegal parameters are relatively easier to be detected. So we wonder, do systems actually react in a better way to errors that, with illegal parameters? This is what we did. So this graph, the red bars shows the percentage of a pinpoint reaction of the overall cases. And the green bar shows the percentage of pinpoint reaction of only illegal parameter errors. And we can see it does react in a better way for illegal parameters, but not good enough. As we can see, most of them are actually lower than even 27%. Because it's easy to detect, we believe developers should have done a better job. Another aspect we want to study is what's the relationship between a message when the system gives to the user versus the diagnose time. In other words, does a good message actually really help user to diagnose the configuration error? To study this, we first categorize all the cases to 3 types based on the message quality. Explicit message means the message clearly tells you what's going on. Ambiguous message means there are some message, but it does not tell you what's the exact problem. And some other case, there is no message at all. And this is what we found. So this is the median of diagnose time normalized to the diagnose time of the explicit message. As we can see, clearly, explicit message significantly reduced the diagnose time. And interestingly, we also find this. So for 3 systems, the developer actually spent more time to diagnose the problem when there is an ambiguous message compared to there is no message at all. So there are several reasons for this, but the major reason is some message actually misleading, so cause the developer go to some other route. So, because I'm a little bit run out of time, I will quickly go through the remaining two aspects and summarize the talk. So, about cost, there are many aspects to analyze what's the cost of a configuration error. And the first question we want to ask is, when does the configuration error happen? Does it happen at the first time the user tries to configure a feature, or the system used to work, it just stopped work in the middle? And what we found is this. For most of the case, it did indeed happen when the user first time configure a feature. But there are also a lot of cases where the system used work, but it stopped work in the middle, which means that the user did something else, and it accidentally breaks something that was working before. Especially for complicated systems, that's the case. And we also analyze these used to work cases in more details, and you can find it in the paper. And I will skip the impact because of the time reason. Okay. So we also studied many other characteristics, and we also analyzed across different angles, and we have more examples, and you can find all these in the paper. Previously, people have done a lot of great work to handle configuration errors. And what we did actually from a different angle. So we want to find the reason why developer introduced these problems. And we want to give developer guidance to prevent configuration errors from the first place. And that's our major contribution. So I have a lot of data and figures in the talk. I don't expect you to remember all of them. So this is my last slide, and it's basically summarizes the guidance we want to deliver to developers. And I want to share a little bit my personal experience with you. So I worked in the industry for several years, and I worked for a company who developed large-scale development tools, and it's used by many other big companies. So when I was there, I used many, many tools. And I was in this situation where I went through this transition. From the beginning, I think our users, our customers, should pay more attention to read the manual because they keep making mistakes, configuration mistakes. And after a while, I transitioned to another end where I think myself should pay more attention to make our product easier to use. So that's why when I came back to graduate school last year, I was immediately attracted by this project, the idea of this project, and I started working on it. So as developer, we spend so much time, so much effort to develop great tools. They are powerful, they solve complicated problems. But if at the end of the day, it's hard to use, it's just not worth it. And our study shows there are actually many ways to improve this. So some of them are a little bit difficult, and some of them are actually low-hanging fruits. So as long as we pay a little bit more attention, we think a little bit more from users' point of view, I think we can make the things much, much better. And once we get all these configuration, not all, most of the configuration problems go away, the user will be happy. And we will also be happier because there will be more people using our stuff. And if that's the thing you want to do, I hope our study can help you in some way down the road. And that ends my talk. Thank you very much.
Yu Feichen from Fudan University. So one lesson you learned from this study is that application should expose fewer parameter configurations that is easy to error prone. So, but in order to make an application more flexible to be used in more environments, I think applications have to provide some kind of parameter configuration. So there's a tension between making an application easy to configure and more flexible. So what's your suggestion to solve this tension?
So that's a good question. I think it's more of an art instead of a science. So there's always a tension between flexibility and simplicity. So I think for some cases, you have to give a user the option to specify, for example, you want to specify the DNS server's address. You have to let a user know. You have to let a user to do it. But I think in general, if the application can automatically configure, it should do it instead of let a user to worry about it. And for those things they have to let the user to do, it's better to do a validation check before they use the user's input. So to make the things much better.
Thank you.
Ivan Bashosnik, University of Washington. So the contribution of your work is a set of practices that developers should carry out in order to avoid configuration errors. Software engineering research suggests another best practice, which is configuration testing. In fact, there are tools to explore the space of configurations automatically. So do any of the projects that you've studied perform configuration testing? And if they do not, how do you think the results would change if they did?
Can you say it again about the configuration testing in software engineering field?
So configuration testing is where you take all the possible parameters to a program and you explore the various permutations between the values for those parameters.
To test if it works.
Yeah. So I'm wondering if any of the projects that you've shown, which are major projects, actually use techniques like that.
To the best of my knowledge, I don't know if any of the system we studied to actually apply this, the technology you just said.
Do they test their configurations in any other way? In any way? Before rolling it out to the users?
I don't know if they test the configuration, but some of them provide configuration tools to help users to configure or help users to validate the configuration before they use it. But to be honest, I don't know if they actually apply the configuration testing process when they develop.
Hi, Jason Flynn from the University of Michigan. If you were to weight bugs instead of by bug report, rather by the downtime or the pain or the frustration that bugs seem to cause, do you think that would change the weightings in your categorization, and if so, how?
I think it's probably hard to measure the frustration in a quantitative way. So
I agree, yeah.
So what we can, well, we do see some swearing words in the forums. But that's probably one way to measure the frustration. But what we did is one of the aspects we studied is the diagnose time. So basically, we measure from the person first asks the question until the person confirms some answer works. We measure this time, so it's kind of approximation to, how frustrated or how hard to diagnose this problem. And we have the result in the paper. Oh. Yeah. There are many good results in the paper. I don't have time to cover here, so please read the paper.
One last quick question.
Ari Rebkin from UC Berkeley. How do you know whether ambiguous error messages are the cause of taking a long time to resolve the problem, or whether, for instance, some kinds of failures both tend to have very ambiguous error messages and also to be hard to diagnose? There's a correlation-causation question there.
That's a very good question. So what we can ensure is, because as I said before, it's very hard to understand the configuration errors because it's just a conversation between the user and people who want to help. So we tried our best to get all the information we can get from the forum. So if the forum says it's explicit message, it's explicit message. If the forum says some message, but it does not actually help to diagnose, we call it ambiguous message. And there are also some other categories.
But that's not what I asked. What I wanted to know is, how do you know that the ambiguous error message made the thing take a long time rather than there's some other common factor that makes them slow to diagnose?
So we see, so if by saying this case has ambiguous message, it's just that we get from the forum, there are some messages. And this message does not really help to diagnose the problem. And then we use the approach, as I mentioned, to measure the diagnose time. And basically, we try to get the relationship between these two. And there might be some case, there are also other effects to affect the diagnose time. And there could be many cases, especially for open source, because Maybe some experts, they take a vacation, so they are not looking at the forum. There are many cases, but we expect these diversity case it contribute equally to all the categories. So to answer your question, we don't know exactly, it is caused by the ambiguous message or it's caused by some other thing. We just get our best knowledge from the forum. Yeah.
All right, let's thank the speaker.
Thank you.